Alright, let's take a look at this problem. Sell diminishing valued colored balls. You have inventory of different colored balls, and there is a customer that wants orders balls of any color. Okay. Okay, we want orders amount of ball. The customer weirdly values colored balls. Each colored ball values number of balls of that color you currently have in your inventory. For example, if you have 6 yellow balls, the customer would pay 6 for first yellow ball. After it is a transaction, 5 yellow balls left, so the next ball is valued at 5. You are given integer array inventory where inventory I represents the number of balls in ith color that initially you own. Just a second. Alright, I'm back. So we were alright. The values, we have two orders. Oh, we have four orders. Alright, then we're just taking the maximum and then changing the value there. So return the maximum total value that you can attain after selling orders colored balls, as the answer may be too large. Return the model. Alright, so we have results or their value basket value. Total value is at start 0, and return total value modulo 10 to the power of 9 plus 7. Okay, so let's see. Where am I? Okay, this is my inventory. So if I have some sort of, if we import heap q and then we create heapify this, yeah, inventory, actually heap q heapify inventory, and then for every I in for every I in range orders, we get heap q that heap pop from inventory, and then we get this value, current ball count, but here this should be, it should be actually minus, let's print inventory. Okay. Okay. So inventory -1, paste it here. Now it should be fine. I just paste it. I mean, for every value, how do I map? Python map. Map function. Right. Inventory is equal to list of map lambda x minus x inventory. Let's see. Yeah, I have the minimums like that. Alright, so I have my negative there. Oops, should be like this. I get that value from there. I put -1 there, and then now I want to add the current ball count to the total value, and then also current. I want to push this. So heap q dot heap push inventory the minus current ball count -1 like this. I just -1 there and put it minus back to it, and then do it similarly, and at the end of this I'll have my total value, which will be like this. So okay, so what if I have this? Right. Time limit exceed, and why is that? Um, What is that? What is that? We do it like this. We change the value there. Pop, push, pop, push. So it is not about heap of I, but it is about I mean, if you have like 10,000 there, that would still give. Alright. It's about this. It's not about heap. It's not about that, yeah. How many times we do this? It's about that. So how do we make this faster? Okay, let's think. How many zeros I have here? 1, 2, 3, 1, 2, 3. Okay, 1 second. Right, so I'm back. So we have time limit exceed problem here, and the reason. So the way to solve this problem, I think I just checked few solutions, and they are most of the time sorting this array and then finding a place where you can possibly have your answer, and for visualization it is basically like, maybe it's better to have it's better to yeah, draw it like this. So you have 3 here, right, and then 5 like this. So in order to have 6 of them, you simply want to have these ones, right? You want these ones, and to know how many you can have, so you can maybe start from so normally if you have like 5 5, right, if these exist, so normally you can have it here like that, but we don't have these, so maybe we somehow perform some kind of like binary search, but maybe in vertical way, like this side. But what do I mean by that is, for instance, if you have, let's go over this example, maybe this one. So if you sort this, you have 2, maybe like, yeah, I'm gonna show it like this: 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Again, similarly, same way, and here again we have same 10 of them here. 3, 3, 3. Okay, so we have this. So for 20, you need at least, this maximum, that you can have here, like, you take this, maybe look at this one, and then you see that you can have 2, and then from here, that you can have like until this point you can have 4. At this point you can have like 2 times, like this is like 1 times 2, 2 times 2, this is 3 times 2, and this 2 comes from this range, these ranges, okay, the differences. And then having that, we can have the maximum, we can calculate the maximum. And how do we calculate this actually? Is so for this we have that, for that we have that. So for this you have 8 times 2 added to the actual total, and here also 8 times 2. But the problem actually is, like, if you take a look at this one, we are like many, right? We have many of them, like many of them in inventory. And how do we solve this problem? Because we have 10 million of those, I guess. So right there, yeah, 1 million there. Actually, what is this? Million, 1 billion. So if we have to count this 1 billion, how do we do that? So we just subtract 1 from that, and then we calculate n times n minus 1, and divided by 2, 1 billion, and do that like that. Well, I'm not sure. Maybe we just search for location. So you have this for 20 of them. You at least need to find the third one, right? The fourth one. You have 10. Actually, this one. Actually, I don't know. I guess I have no idea to solve this in limited time. So this works, I know it, but it is TLE. So I guess I will check the discussion and then continue with it. So because I couldn't find a way to do this, but maybe, yeah, like, so what's my complexity here? N log n, right? And then this is n, this is n log n. I mean, n log n should work, but when we have something like this, I guess so if you sum from 1 to n, right? So 1 to 10 is 5 times. No, it is 10 times 9 divided by 2. This is 45. And minus 5. If you want from 5 to n, 5 to 9, right? If you want 5 to 9, this is 45. 5 times 4 divided by 2 is 20. You have 25 there, right? So 5, 6, 7, 8, 9, 10. This is 15. This is, but do I include 5? I think we included. This should be normally, yeah, this is 45 actually. Okay, from 5 to divided by 2. Ninety divided by 2, 45. It is plus 1, alright. I made a mistake. So this should be 11. This should be 6. So times, okay. This is 55. this is 15, 30, yeah, this should be now 40. Okay, so okay, so this should be 40, it's 15, 15, 15, 15 is 45. What is that? I add yeah, it should be 5 times, actually it should be 4 times 5, should be 10, because I want this side, I want to remove this side. Okay, so when we do that, we simply here, if you want to calculate that, so times maybe just do it here, divided by 2 modulo 1, 2, 3, 4, 5, 6, 7, 8, 9, and turn this to 7. Python. Okay. Should be something like that. Maybe if we just do that. Okay, so that works as expected. But then do I have to perform this every time? Just one operation at a time? So instead of adding this, what I can do here is that if I have another, so if inventory is not empty, else you just do it like that. Total value, just 1 second. Okay, so if I just go back, I can go that back. Okay, if I have this, I calculate that. So okay, I don't want to do this now. I want to move this down. So I pop it, right? I pop the biggest one. Now I have 1 million there, 1 billion there, right? And I have to perform this. And if it is this, then I just want to add. So remaining order will be my order. Okay, while or orders. Here, let's say that I have like 1 billion order here. For that, so 1 billion, a little bit more than the value that I have. So here are that many from that current ball count. So current ball count minus order, remaining orders will be my new value to be added will be remaining balls. So for that, we will simply do this. We'll calculate it, and here I'll just break here. But just before that, I have to change my total value to this. Remaining balls that I have to take will be 0 at this point. From 0, calculate remaining balls. Okay, I have to do this. Remaining balls times remaining balls plus 1 divided by 2 minus current orders times orders plus 1 divided by 2. So 0 times 0 plus 1 will be 0. Add that 1 to there. Pass. Okay, this should return me that. It should be correct with million. So this should be divided by 2. Okay, like that. Now it should be correct. And also here, I should do similar operation where now I have some remaining. So here, so I have 2. All right, I have 5. From here to here, I'll calculate the number of balls I have using that. And so I have 2, I have 5. How do I calculate this? I'll simply do this formula here. Actually, just simply the same thing here. I don't even need this. But at the end of this, by the way, I will just, when I pop this, I will every time, if I have many of those, Hmm. Mm-hmm. Actually, what if I do this? So it works, right? What about what if I it will be TLE, right? Hmm. Yeah. Okay. And I might do it like I said. But what if I have like million there, million. Like this goes down like this one, first million of them. This should also work, right? So I should calculate together. Hmm. I'll check it again. All right, I checked the solution. It's kind of working as I expected, but it's kind of hard to calculate this multiplication there. And also, I was using heap. I should be sorting this list in like descending order. And so my logic is almost like correct, but I'll be trying to implement this later on. So yeah, for now I'll just stop.